Whenever you report the center for a distribution, you also want to describe how much the values in that distribution vary from the center. And so looking at each of these three data sets, all three of them have a mean of 75. But you can see that they each look very different. The first data set, they're spread out from values 50 to 100. So even though the mean would be 75, that really doesn't represent what a typical value is. Now in data set 2, the average is 75, and we do have a lot of values there at 75. But that 50 and the 100 there on the ends are not appropriately described just by saying that the mean is 75. Now data set 3, saying that the mean is 75 would capture what information. So in data set 3, saying that the mean is 75 would certainly capture a lot of information about this data set. But it is essential that we have a value, a measurement that we can use for these data sets to describe how these distributions vary from the center. In data set 3, that value is going to be very small because the data is very close together. In data set 2, it will be a little bit bigger of a number to describe the spread because we need to explain that there are some values further away. And then in data set 1, we're going to have a much larger value than the other two data sets because the values vary greatly from that mean of 75. Now we certainly can do a simple calculation finding the range where you just take the largest value minus the smallest value. There are definitely some times when giving the range is important, but we are going to look more at the standard deviation to describe our data sets. So we can start by understanding what a deviation from a mean is. So the deviation from the mean is simply the observation minus the sample mean. And these are used in calculating the standard deviation. So let's look at this data set where we're looking at Big Mac prices in US dollars for different countries. So first thing we would need to do is calculate the sample mean. So if you put all of this into StatCrunch and went to stat calculations and got your summary statistics, you'll see that X bar would be $4.07. That is the average value for these countries. Now we're going to take each observation, each price, and subtract the mean from it. Values that are below that mean will have a negative deviation. Values above that mean will have a positive deviation. So you can calculate that for each price in the data set. When you add all of these numbers up, you'll find for every single data set that this sum of the deviations is going to be 0. And that's because the mean is this balancing point. It's the point in the data set that balances the weight of the values above and below. So if your sum of the deviations is anything other than 0, you did something wrong. But now that we have these deviations, we want to calculate the standard deviation, which is kind of like thinking about the average of those deviations. We first start with the sample variance. That's S squared. And you're going to take all of those deviations, you're actually going to square them. That way we won't have to worry about the positives and negatives, and the sum was 0, so we want to do something where our sum is not 0. And then you divide by n minus 1. Now usually when we're taking the average, we divide by n, but because of a few concepts and statistics that are beyond the scope of this class, we need to divide by n minus 1 in order for this to be an appropriate measurement for a sample data set. So the variance is calculated by adding up all of those squared deviations and dividing by n minus 1. The sample standard deviation is then calculated by taking the square root of that value. So if we were to go back to our Big Mac data and you see the deviations from the mean, we square all of those. We'll add all of those values up, and then we divide by n minus 1. In this case, there were 12 observations, so we would take that sum, divide it by 11, and we would get 0.1902. That would be the variance. But typically we report the standard deviation, which is the square root of that. And in this case, it's 0.436. So we would describe the mean as being $4.07 with a standard deviation of about 44 cents. That helps us know that most of the data there is going to be around $4.07, and you can expect typical values to be within 44 cents on either side. Now, just like we had the population mean and the sample mean, we have the population variance and standard deviation, and we have the sample variance and standard deviation. We'll use S when we're dealing with a sample, and we'll use the Greek letter sigma when we're dealing with a population.